So today what we're doing is we're learning about radians. So far all we have learnt about and to do with trigonometry is measuring angles in degrees. So radians is another unit of measuring angles, and there's also something called gradians as well, or grads. So a radian is a unit for measuring angles based on our arc in a circle. So it is the arc length as a multiple of the radius of the circle. That is the ratio of the arc length to the radius. So what we have is that 1 radian is the angle subtended by an arc length with length radius r, okay? And so our radius, what that means is that our radius is equal to our arc length. They're the same, and that's worth 1 radian, where the radian is the angle in there. Okay, we know how many degrees and radians are in a full revolution. Okay, so what we have is that we know that there's 360 degrees in a full revolution, so that can help us find out how many radians there are. So the circumference of a circle is, how do we find the circumference of a circle? We use C equals 2 pi r. Okay, so that means that the number of radians in a whole circle is 2 pi. Okay, so what we have is that the number of radians in a whole circle is 2 pi r over r, which just equals 2 pi. Okay. But we have that there are 360 degrees in a whole circle, which is our angle of revolution. So what that means is that 2 pi is equal to 360 degrees, and that we have 1 pi would equal 180 degrees. Okay, so 1 pi is a type of way that we can express radians. Okay, because radians aren't necessarily going to be nice and whole. They're used as decimals, but pi helps us do it with exact. So pi radians is equal to 180 degrees. So how we convert x from degrees to radians is what we have is that, what was I going to do? We have that 180 degrees is equal to pi radians. Okay, so what this means is 1 degree, if we can find 1 degree by dividing everything by 180. So what we have is that 1 degree is equal to pi over 180 degrees. So to get x degrees, how we find x degrees is we do x times pi on 180. Okay, so how we convert from degrees to radians, so if we start with degrees to get to radians, what we do is we multiply by by pi on 180. Okay, that's nice and easy to remember. Then to go the other way, so to convert from radians to degrees, what we have is that pi radians is equal to 180 degrees. So to get to 1 radian, we have to divide by pi. So what that means is that 1 radian is equal to 180 over pi. So to get x radians, all we do is multiply x by 180 over pi. Okay, so we multiply by 180 over pi. So whatever we're trying to get to is on our numerator, and whatever we're coming from is on our denominator. Okay, so what we have is that 1 degree is equal to pi on 180, like we just discovered up above. So that is approximately, if you were to go pi on 180 into your calculator, that is equal to 0.017 radians. Okay. Then 1 radian is equal to 180 on pi. So 180 on pi in degrees is 57 degrees and 18 minutes. Okay, so that's how they connect to each other. Okay, let's have a little look at some of the examples. So the first examples, what we want to do is convert 3 pi on 2 to degrees. So we're going from radians to degrees. So we're using this pink method, if that helps you. So what we'll have is we'll do 3 pi on 2, and we are multiplying by 180 on pi. Now, do we see what's going to happen when we multiply by 180 on pi? The pi's are going to cancel each other out. Okay, we can just put this into our calculators though, and when we do that, what we get is we get that it equals 270 degrees. Okay, example 2, we want to change 60 degrees to radians. So we're starting from degrees and going to radians. So we're using like the green method, okay, and we're going to leave our answer in terms of pi. So what we're going to do is we start off with our 60 degrees and we're going to multiply it by pi on 180 degrees. Okay, what we have is that we'll have 60 over 180, and that 60 over 180, that simplifies down to pi over 3. Does that make sense? Okay, if you have the new calculator, you can go 60 times pi on 180 and it will come up as pi on 3. If you have the old calculator and you go 60 times pi on 180, it's going to give you a decimal, okay? It's not going to give you the exact answer. Pi on 3 is equal to 1.047, etc. Okay, but we want to leave our answer in terms of pi, okay? We want those exact values. Okay, moving on to the next page. What we want to do is convert 50 degrees into radians. So we're going from degrees to radians, so we're using the green method, but this time we're doing it to 2 decimal places. So we're starting off with 50 degrees. We are then going to multiply our 50 degrees by our pi on 180. And when we do that, 50 times pi on 180, what we get is, to 2 decimal places, 0.87. Okay, our next one, we want to go from radians to degrees. So we have 1.145 radians, and we want to get that to degrees. So we start with our 1.145. We then multiply that by 180 over pi. So 1.145 times that by 180 over pi. And what we get to the nearest degree is we get 65 degrees, 36 minutes. Okay, example 5, we're going from degrees to radians, correct to 3 decimal places. So we start off with our degrees of 38 degrees 41 minutes, and we are multiplying this by pi on 180. 38 degrees 41 minutes times by pi on 180. What we get to 3 decimal places is we get 0.675. Finally, what we have is to evaluate cos 1.145 correct to 2 decimal places. Okay, what we do is we just type in cos 1.145, but we need to make sure our calculator is in radians. So we have to change our calculator to radians. So how we do this, calc to radians, is on our calculator, depending what type of calculator we have our instructions here. So if you have the new calculator, the FX8200 AU, you need to go settings, calc settings, angle unit radians. If you have the old one, you just go shift mode 4. Okay, what you should have on the top of your screen is you should have a little R. Okay, that means that you're in radians. When we put that into our calculator, so when we go cos 1.145 into our calculator, we're going to get 0.41. Okay, if you still had it in degrees mode, okay, you'd get 0.999. Right, so we need to make sure we change our calculator into radians. Now, we have some special angles when we're dealing with our radians. So pi on 6. So pi on 6 in degrees is 30 degrees. Pi on 4 is 45 degrees. Pi on 3 is 60 degrees. Okay, and pi on 2 is 90 degrees. Because pi is 180 degrees. So if we divide 180 by 6, we get 30 degrees. If we divide 180 by 4, we get 45, etc. We also have our exact ratios in radians. So we can use our triangles to help us out, but we have that sine pi on 6 is the same as sine 30. Okay, so that is equal to a half. We have cos pi on 6 the same as cos 30, which is root 3 on 2. We have tan pi on 6 the same as tan 30, which is 1 on root 3. Now, sine pi on 4 is the same as sine 45 degrees, which is 1 on root 2. Cos pi on 4 is the same as cos 45 degrees, which is 1 on root 2. And tan pi on 4 is the same as tan 45 degrees, which is equal to 1. Finally, our sine pi on 3 is the same as sine 60 degrees, which is equal to root 3 on 2. Our cos pi on 3 is equal to our cos 60 degrees, which is equal to a half. And our tan pi on 3 is equal to our tan 60 degrees, which is equal to root 3. Okay, so we can get our reference sheet and we can look at our triangles. I'll go to the annotated version. Okay, we can look at our triangles and we can write on there that 45 degrees is really pi on 4. We have 30 degrees is pi on 6. And we have 60 degrees is pi on 3. Okay, and then that's how I was getting the answers to those ratios. All right, we have some more examples. So the rules and formulas of trigonometry can also be expressed in radians. So the same as what we did in degrees with our rules and formulas, we can also do here. So if we were to find the exact value of sine 5 pi on 4, what we want to do is we want to work out where sine 5 pi on 4 is. Okay, so what we have is we want to work out how many more lots of pi it is, or we can break it down. So what we can say is we can say that 5 pi on 4 is equal to 4 pi on 4 plus pi on 4. Okay, which then this is just equal to pi plus pi on 4. So if we're pi plus pi on 4, what we have is, if we look at our ASTC, which we can either look from up above or down below, we have our 0 degrees, our pi, and then our 2 pi is over here. Okay, our pi on 2 is up the top and our 3 pi on 2 is down the bottom. So we are going to be, with pi plus pi on 4, we are going to be in our third quadrant, okay, because we are greater than pi. So that's pi plus our theta in there. So what we have is we're in our third quadrant. So if we're in our third quadrant, what we have is that we're actually negative there. So we're going to have that sine 5 pi on 4 is equal to negative sine pi on 4. Okay, and then we can see that sine pi on 4 from up above, or from using our calculator, or from using our triangles, is 1 on root 2. So pi on 4 is like our 45 degrees. Okay, our next one we have cos 11 pi on 6. Now 11 pi on 6, that is very close to 12 pi on 6. Now 12 pi on 6, that is the same as 2 pi. So what we have is that 12 pi on 6 minus 1 pi on 6 is the same as 2 pi minus pi on 6. So what we have is we're over in our C quadrant. So over in our C quadrant is where we have 2 pi minus our theta. Okay, so what we'll have is that cos 11 pi on 6 is equal to, now cos is positive over there, so it's going to be positive cos 1 pi on 6, and cos 1 pi on 6 is just equal to root 3 on 2.